Right. Hello and welcome. Just check if my sound is working. Good. Welcome to topic 1A, where we are discussing the concepts first in topic 1, and that'll be followed then afterwards in the next videos by actual calculations we do from start to finish. And this one is on displaying data. Collect some information, we have some information, we want to convey that information effectively. We want to present it in a way that makes sense to us as well as whoever may read it. Now, there's not a lot of writing in this one, but I have some slides here that we can go over. I'll just make my cursor smaller. So let's review what we did mention last time in our introduction, the difference between these key words, a variable, a value, and a score. The variable is the characteristic that we are investigating, we're testing, we're gathering data for it. The value of that variable, the values, are the possible let's think of numbers, possible results, possible numbers we can get when we measure that characteristic. So think of something like stress level, age, gender, religion, all kinds of things. There are different kinds of variables. We have nominal or categorical variables, different names, because why not? Where it's more of a classification of groups, not a number, and there's no order to that. And then we have our numeric variables that can be a ranking or just what we call an equal interval or interval variable, where I just have a number measuring something like height or weight or stress level on some scale or the age of a person. Lots of different number possibilities. The value, if I think of age, all the possible ages, age numbers I could get. So it has a range of possibilities. The score is the number that I actually get when I measure a person or interview them or assess them in whatever way, whatever I'm trying to measure. If I'm trying to measure stress level, I might give them a questionnaire, and depending on their answers, they get assigned a number that is their stress level. That is a score of the variable out of all the possible values it can have. If I am looking at age as my variable, then I interview the person specifically out of the whole population of the country, maybe, or the world, see what their age is. That is a specific person's result out of all the possible values. That is a score that I get. And I can get, of course, multiple scores that are the same. If I think about a categorical variable, I interview a person, get their religion based on a few categories. That is a score as well. So it doesn't have to be a number, but it's certainly fine if in the beginning, as you're getting on top of these concepts, think of a number, think of something simple like age or height or weight, something that we're familiar with. So let's look at an example. And in this example, this is just an example here. In this example, people were interviewed. How many people? Well, we got scores for a bunch of people. I didn't count that beforehand because I want to do it with you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 5, 36, 37, 38, 9, 30. So 30 people were interviewed. and we get their stress rating somehow. We're not interested in exactly what the questionnaire was right now. We have some data, we want to present that. And the list of numbers here is not a very good presentation. At the very least, we can present that by way of a table, right? So we look at all the scores that we got, and that gives us an indication of the range of values for this stress rating variable. The smallest one is certainly a 0, the highest one seems to be a 10. So it ranges from 0 to 10. Now I'm going to see how many times does each of these values occur in my collection of actual people, actual scores. So I go, it's a little tedious, but if I do it by hand, which is our first step, I have to go and say, okay, 0 occurred once only. That is my frequency. Say here, how many times does it occur in my collection of scores? I look at 1, there's 1 there, and I go down the list and I see, oh, there's a lot of 7s, fair number of 6s, 8 occurs 5 times, 9 occurs 3 times, 10 occurs 3 times. So I do have to count carefully, and I can have a little test here. If I add up the frequencies, let's say it over here, the sum of, actually I'm going to do it on the other side, use that side for something else. The sum of the frequencies, we can check. Do we get 30? Well, if I count how many I have here and I add up the frequencies and they're not the same, then I missed one, which is very easy to do. So add up the frequencies and check, do I get 30? Yes, I do. Now, it's not a guarantee that I did it right, but at least it's a little bit of a safety check. All right. So yes, that's good. The frequencies tell me how many times it occurred, but what if someone else interviewed only 20 people? Or someone else interviewed 100 people? These frequencies are kind of relative to how many I interviewed or how big my group is. So it makes much more sense to do what we call a relative frequency, where I'm going to take this 1 and I'm going to divide it by the total. I'm going to take, let's do this one, take the frequency. I'm just going to skip a few because my fractions are a little big for each, for the row. And I'll say my relative frequency is 2 out of 30. That's a fraction. I can make a decimal, but that doesn't easily show where it comes from. For 7, for the score 7, the frequency is 7 as well. Don't be confused on what these 7s mean. I get a relative frequency. Now, of course, fractions aren't really anyone's favorite. Converting that to a percentage is a little bit more presentable. So there could be percentage signs here, right? So 1/30th is 3.3%. And all I do is I multiply that by 100. That's how I get the fraction or decimal to a percentage, and so on. And if I add up all the percentages, add up the percentages, which is just another version of the relative frequency, I should get 100%. Because I'm every person, 100% of my people, 100% of my scores are in here somewhere, and only one. And one, how should I say it? One each is in here. Any specific score only occurs once in one of these frequencies. But presenting it by way of a table is definitely a step forward to making it more readable, conveying information more effectively. Frequencies relative frequencies and the percentage version of the relative frequency. So that is certainly a good step. Let's just briefly look at another one. Nothing is going to change. I have another example here. It's just kind of interesting and funny. I'm measuring hostility as a delay in seconds for 29 people, 29 cars before they honk their horn at a stalled car when the light has already turned green. So you're behind someone, the light turns green, the guy doesn't go. How long does it take for you to start honking at him? That could be a measure of your hostility. So they tell me 29, and if I count these scores, 29 is what I should get. Now, to make it simple, because we're doing it by hand, technically I could measure it in any kind of fraction of a second, but they've made it easier, and the options are only seconds or half seconds. So this first person took 3.5 seconds before they honked. This person was more hostile. They just honked right away, and I have to look at my range. So it goes from 0 to, that's the largest one here. I see a 5 up there. The calmest person was taking 5 seconds. So what I could do, if it makes it easier for you, is not necessary. You can have a little tally system here where I list everything and then I mark. Okay, 3.5. I see it there. 1 tally mark. 2, I see it there. Another tally mark for 2. And I go down the list and tally everything until I reach the end and then just count. Oh, that one occurred once. 0.5 occurred once. If I look here, 3 seconds occurred 1, 2, 3, 4, 5 times, and I get my frequencies again. Now, it's not necessary to include a relative frequency as well as a percentage. You could. It's not necessary because the percentage is the relative frequency, just in percentage form. So it doesn't really matter. But whatever form, it is important to have a relative frequency. It carries more meaning than the actual frequencies because the actual frequencies are very dependent on how many cars I tested. And I can have a check here, do check that I get 100%. I'll leave that to you as a little safety to make sure I didn't miss anything. Now you can argue that, in general, if I think about a more realistic situation, though they've simplified it for me, I can get any fractions of a second. Or I can get 1.1 seconds. I can go even more specific and more accurate. So it makes sense to perhaps group this into some groups. Let's say the first second, second, and so on. Well, sized groups, but still, depending on how specific I am in the time, if I measure my time to 2 decimals and allow for anything, I don't round it at all, I could get 3.57, 2.12, and I can be so specific that nothing repeats, and I get frequencies of 1 everywhere. Or I have just too many possibilities because my splits in possibilities is too fine. So I can group the possible scores, the values of the variables, so that I get something more meaningful in the frequencies. Not necessary in this case, but if I think more realistic, grouped frequencies might be better to present the information. So I have options in my frequency table as well. And it becomes a little bit subjective what really conveys the information that is represented here. It is a little bit subjective. How big do I make my intervals? Yeah, there's definitely uh, some options there that you choose. And as a reader, you decide, well, the frequency table that's presented, do the intervals make sense? Are they too big? Are they too small? Too small, and I sort of lose any information, any significant information. Too big, and too much is captured in a single interval. There's a sweet spot that might require some trial and error. So a table is good, but most of us are pretty visual. It'll be nice if we can look at alternatives to present this. Before we do that, however, let's just go through the steps. Just a guide. Don't look at it like, oh, I must follow 4 steps and no more. It's just a recommendation, right? Make a list for all the possible values. Get your range of values that you can get, your range of scores rather. Go one by one and mark them with a tally system or count the frequencies and then make a table with those frequencies and a relative frequency by way of percentage. Percentages are easy for people to understand. Graphically, this might be even nicer to present and visualize. Let's go back. Let's not go back, but let's stick to the horn honking example. 29 cars. Let's go with our groups. So it's less for us to do by hand. If we're doing it with software, of course, we can test and try many different groups. So now all we're going to do is look at our groups here and have a little bar positioned on the interval. So it's from 0 to 0.9 is my first bar, and it has a height of 2 because its frequency is 2. The next bar is going to span the interval. Midpoint isn't super important to list in the table. It's just for clarification that it's centered, of course, in the halfway point between these two extremes, or it is spanning my interval. And its height, again, is its frequency. And I get this visual profile that immediately, without me even looking at numbers, immediately it conveys information to me. It tells me how the scores or the possible values are distributed across the possible, how the values are distributed across everything that is possible. I can very easily make the height of these bars the percentages as well, because it's all relative, right? They'll be proportioned the exact same way. And this graph we call a histogram. And it gives me an approximation for what the profile of this variable actually is. I don't know if it's how perfect it is because I only took 29 cars and examined them. If I took more cars, the profile might change a little bit, but if it's nice and representative, we see that there's a spike in the middle and it drops off a little bit faster on the right than it does on the left. It's not quite centered, right? So by way of a histogram, we get a nice graphical interpretation for a reader and for ourselves. So here, all these things are done for us. I remind you that this is 1A, and the A stands for just acquiring the knowledge, learning about a histogram, and so on. In the follow-up B videos, we will actually do this by hand and see our options and sort of reinforce the concepts again. So let's just review that quickly. When I'm making a histogram, it comes from my frequency table. So I do everything again for the frequency table. Then I need to see my values, whether it's groups or individual values. Once I have them, regardless of if the frequency might be 0 for some, I can't skip any. I have to list them all and graph them all. And then make a scale, have frequencies along the left edge of the pane. Yeah, okay, fine. It can be frequencies or it can be percentages. It's really up to you. The profile will look the same. And make a bar of the appropriate height for each one. standard rule is for a histogram, it depends on the variable, but for a variable where everything is possible in this range, my bars ideally should touch. However, it does depend on the variable. And if I have another kind of variable, like a categorical or nominal variable, then it doesn't quite make sense. If I look at this example, closest person in your life for 208 students. See, that got away from me there. So they had a questionnaire, and this was one of their questions. And the choices were a family member, a non-romantic friend, romantic partner, or other. Now, it doesn't matter how I list these, right? There's no order to the values of a categorical variable. So there's no real range. I just have to list all the possibilities. I get these frequencies, calculate the percentages, and remember, we are going to do those calculations in upcoming videos. Right now, it's all done for us to just get the concept, understand the concept. Here is what we now call a bar graph, not called a histogram. Someone decided, no, you can't call this a histogram. We call it a bar graph for this kind of variable. There's no order here, right? I could have easily listed in the other way, shuffled them around. So the profile, we can't read much more into it. You can only see how they compare with each other. Whereas in the case of a histogram, this profile is linked to the variable itself because there is an ordering to the values of the variable. In the case of a categorical variable, that's not the case anymore. So I guess we try and help tell the two kinds of variables and what I should read into this graph, tell it apart by having a gap between the bars, calling it a bar graph, having them touch, calling it a histogram, to help me distinguish between the two. But the concept of visualizing the information is essentially the same in terms of my goal, what I'm trying to do here. Right. I don't want to beat this to death, but there is a little bit more when we think about the histogram and the profile that it is suggesting by way of just a few. Remember, we just took 29 cars. We got this profile, this distribution of how the values occur across the range of values. Not that one, not that one. You see, I can get different possibilities for what we call the skewness. I can get something that's nice and balanced. The peak sits right in the middle and it slopes down in the same way to either side, an isometrical profile. But I can also get the peak to sit a little bit to the left and it slopes down to the right longer. It has a right tail, and we call that a positive skew. So the long slope is on the positive side, positive skew. And I can get the peak sitting on the right and the long tail is on the left to the negative side, negative skew. Now, with more sophisticated software, you can calculate the skewness index. It's a little bit too complicated to do by hand, and it's not the focus here. And it'll give you a positive number or a negative number or a zero to indicate which of these are happening. Because sometimes in a graph, when it's a little bit positive skew, you can't quite visually tell. And sometimes it can have multiple, oops, not that one, multiple little peaks, and it's hard to visually just say, oh, it has a positive skew. How skewed is it? Like that may be important. Here are some examples, just very briefly. It doesn't really matter where they come from, of histograms coming from actual scores that can have different skewness. Number of children versus number of families. matter what the example is, I can easily get a positive skew like that when fewer families will have a lot of children, right? More common to have 0, 1, 2 children. Or I can have a negative skew where I look at a test and how many people got a certain percentage of correct answers, depending on the test, of course. Maybe it was a super easy test. A lot of people got 100%, and fewer got nothing. A negative skew profile comes often from a variable like that. So I have this skewness that I just want to have that key word and that basic concept, and that's all for now. We also have another concept, and this is the last one, called kurtosis, which is an indication or refers to how narrow or a little wider the distribution, the profile is. We have sort of a reference shape that we'll introduce later in the course called the normal distribution, and sort of that has a zero kurtosis, something that is a little bit more narrower, more peaked, is relative to that, has a positive kurtosis, and something a little flatter and wider has a negative kurtosis. So just like for skewness, you can calculate a kurtosis index, and that'll tell you how it compares to this baseline normal distribution, because visually it's hard to uh, assess from the graph itself. On top of that, the histogram is just an approximation of that underlying distribution. But these concepts, in different degrees, will come back and be repeated as we discuss future topics. Just some examples here, very briefly. We have, you can very easily get something that has sort of a peak standing out, but pretty narrow in terms of its how fast it drops off. High kurtosis or positive kurtosis. Or you can get something where the frequencies are pretty much the same throughout, very sort of lower and wider distribution, more uniform, and that'll have negative kurtosis index. So again, just the concepts. The most important ones here are that of a histogram. How do I find it? The process involved. And in the upcoming lectures, we will do actual examples to reinforce that. But that is it for now. See you in the next video.